Hi. A couple of weeks ago, the Swedish Army had a hackathon, which was open for the general public, this sparked an inspiration for an idea I had about how to basically fight on the same map, and the one of the prerequisites of the hackathon was to use the ATAK server. So what you see on the screen up to the right here is the WinTAK client, then obviously you can have a ATAK, the Android version of the Tactical Awareness Kit, and I also have the WebTAK up and running here. So in the back end, I have a ATAK server, that is the fundament of this solution. I'll talk you through what this is and what my idea is. But the prerequisites was a hackathon based on doing something with a ATAK server. So what you see here now is I have two troops. This is the one where I'm positioned at now, and this one beta is the WebTAK. So the main idea behind the solution I'm calling Aurora Bridge is speed, reducing the time between detection and engagement. So the use case here is the user is a troop, and what they do is they detect an enemy on the field, and what I'll do is I'll just drop an enemy near the airport here. So this visual detection, I'll set a tag on it. Let's call it just a car. So this is the car, and some type of enemy troop. And what I'll do is I'll send this information, I broadcast this information. So this is broadcasted now, and what happened is I have the ATAK server contains a messaging server, a cursor on target. So I've written a server-side monitoring software that monitors this stream of data, and as you probably can see somewhere here, we have received a message called car. So this is sent to the server, and the solution is then to visualize this on a map. So what we can see here now is the Aurora solution. So let's see, the enemy car has arrived, and you can actually see it on the map here as well. Again, this is the same source map that is used in the different ATAK clients. So we're fighting on the same map, and this map is provided by T-Carter and is a OpenStreetMap. So this enables us to see exactly the same thing depending on or independently of where you are in the network. So you see here now in the Aurora Bridge, a hostile known unfriendly appeared on the map here, and I can also see that within the radius, the engagement radius of different troops, we have two different types. You have a Troop 1, which is a ground force. They have a reach of 5 kilometers. And the number of kilometers to the target is 3.2 kilometers. Engagement time is 42 minutes. So it's marked as red because I have added different layers or different levels of engagement priority. So red is too long. Then I have a Archer. It's this one down here. Archer 1 it's called. I can see that the notice to move is 10 minutes, so it's 10 minutes from the time that they get the call to until they can engage, and the reach is 20 kilometers, and the speed is 1,000 kilometers for the artillery shell. Those are just made up numbers. but I can see that the engagement time is 11 minutes. What I'll do is just to show how this works is I'll take this marker and I'll move that in as well. So I'll move that in and see how it overlaps the enemy now, and I'll call this Archer 2. It has the same speed on the artillery shell. Notice to move is I'll set that to 5 minutes instead, and then I'll save this marker. And what happens now is I'll just reload it because so it goes faster, but usually it will pick that up within a couple of seconds. So what I'll do now is I'll see that now we have a couple of overlapping units, and it turned up here as well, and I can see that the engagement time is now 6 minutes. So the troop that saw the enemy at the first place can send this information upstream, and then at battalion level or higher they can actually choose who's going to engage the troop. Also, this is obviously good for any other type of information that needs to be sent upstreams to battalion or higher levels. Before we go on, the entire stack here is based on Docker and Kubernetes, so it could be deployed on a closed mesh network, so you could work on this in the field and close down to the specific units that are going to use, and even the maps can be cached down also. And the good thing about the maps here is as they're based from the Iris TK Auto Service server, it could actually be that even if they fight on the same map, we can, for the TAK units, the end client units, they can get a portion of the map which is much smaller, and then going upstream again, the size of the map that they can see is bigger. So you could actually differentiate what you see and what you don't see, even if you're using the same map. So what I'll do now is I'll say, okay, let's the Archer 2 engage. So what I'll do is I'll send an engagement. This is sent. And what I'll see now on the TAK client is that I got the Archer 2 engaging car. So now the troops, this is a broadcast message. So both the beta and the alpha group will see that Archer 2 is engaging the car. And in a couple of minutes, this icon will be removed when the alpha troop has validated the impact of the work of the Archer. So basically this is the demo and inspiration I got from the Army hackathon, which I couldn't participate in, but you get the idea of how information can be streamed upstream and let headquarters decide who and what is going to engage the different enemies. So you get a distributed way of handling this type of engagement. So I don't know if this is useful at all, but it was a good test for me to see how the TAK server works, and again with services like the tcarter maps and also with just a fundamental PHP and JavaScript coding, I got the solution up and running in quite a short time. Thank you for watching.